Dear students, today our topic of discussion is peripheral devices. This topic is from the subject microprocessor for 4th semester EC students. Myself Sanjeev Goyal, I am working as senior lecturer at Government Polytechnic College Bathinda. First of all, in a microprocessor based system, the designer has to select suitable memories and input output devices for his tasks, and these devices are interfaced with the microprocessor. The selected memories and input output devices should be compatible in speed, in voltage, etc. with the microprocessor. But if a particular device is not compatible with the microprocessor, then an additional electronic circuit has to be used, and that circuit is known as a interfacing circuit. So, a microprocessor has to be interfaced with various peripherals to perform various functions. For example, there is a interfacing of memory and input output devices. There are two types of interfacing in context of the 8085 processor, that is memory, and second one is the input output interfacing. To communicate with outside world, microcomputers use peripherals. These peripherals are connected to the microcomputer through electronic circuits known as interfacing circuits. Such interfacing circuits or devices can be programmed in a number of manners, in number of ways. So, these devices are programmed devices. These programmable peripheral devices were introduced by Intel to increase the overall performance of the system. So, there are some devices which are used to interface these input output and memory devices with the microprocessor. These devices are known as interfacing devices, and these interfacing devices are programmable. That means, we can program this according to our need, and these are designed by, introduced by Intel to increase the overall performance of the system. These devices, along with input output functions, they perform other functions, various other functions also, such as time delays, counters, interrupt handling, etc. So, they are not only for the input output function, they have done used for other functions also, that is for timings, for delays, for counters, for interrupt handlings. These devices are nothing but a combination of many devices on a single chip. A programmable device can be set up to perform specific function by writing a code in its internal register. As this code controls the overall function of this particular device. So, this code is known as a control word, and an internal register in which this word is stored is known as a control register. So, as these devices are programmable devices, we can program this according to our need, and we have to use a control word, and this control word is stored in the control register. Intel developed some peripheral devices for processors like 8085, 8086, etc. Some of the peripheral devices which are used for microprocessor 8085 are 8251, it is serial communication interface, or it is also known as the USART. 8253, programmable counter interval timer. 8255, it is parallel communication interface or programmable peripheral interface. Then 8257, that is DMA controller. 8259, that is programmable interrupt controller, and sixth one is the 8279, that is programmable keyboard and display controller. So, one thing is common in all these devices, that these devices are programmable. We can program them according to our use, according to our need. First of all, 8251, it is serial communication interface, or it is also known as a USART. It is a programmable communication interface. It is also known as a USART, Universal Synchronous Asynchronous Receiver Transmitter, and it is used for serial data communication. Programmable peripheral designed for asynchronous as well as synchronous data communication. So, it can be used for asynchronous as well as synchronous serial data communication. It is a 28 pin device, 28 pin IC. It receives parallel data from the CPU and convert it into the serial data up to conversion, or it receives serial data from the outside and convert it into parallel data to send to CPU. Its functional organization configuration is controlled by a program, a software. The operation between 8251 and CPU is executed by program control. This is a pin diagram of 8251. There are total 28 pins, and this is the block diagram of 8251 programmable serial communication interface. It has having 5 blocks, that is data bus transfer, then read write control logic, modem control, this is a transmitter section, and this is a receiver section, and there are total 28 input output pins on this IC. So, sections of 8051, it has 5 sections: data bus buffer, read write control logic, modem control, then transmitter and receiver section. First of all, data bus buffer, it contains data bus from D0 to D7. This is 8-bit data bus used to read or write status or command word or data from or to the 8251. So, we can read or write anything that is status, we can read the status, we can write the command, or we can read or write the data to or from 8251 by using this 8-bit data bus D0 to D7, and this bus is connected with the data bus of microprocessor 8085. Then second section is the read write control logic. It includes the control logic, that is here. It includes the control logic, and it is having a 6 input pins which control 6 input signals and 3 buffer registers, and these registers are data register, control register and status register. Data register is used to transfer data, control register is used to transfer control word, whereas status register is used to read the status of 8251. First of all, control logic. It interfaces the chip with the microprocessor unit, determines the function of chip according to the control word in the control register, and monitors the data flow. So, control logic controls the overall function of 8251, that the function is controlled through the control word. So, the control word is in the control register, and it also monitors the data flow, that is either read or write. Then CS, that is chip select, this is the active low input signal. When this signal goes low, the 8251 is selected by the microprocessor unit for communication. So, this chip 8251 is only enabled by CS bar becomes low. Then CD, C means control, D means data. This pin is indicates whether the data buffer contains controlled word or data. When this signal is high, the control or status register is addressed. When it is low, data buffer is addressed. So, it indicates whether the control or status register is addressed or data buffer is addressed. When it is high, it indicates control register is addressed. When it is low, it indicates data buffer is addressed. Control register and status register are differentiated by write and read signals, because we have to only write in the control register, whereas we have to only read from the status register. So, the differentiation between control register, because the only one register which acts as a control as well as status register, but the read and write functions differentiate whether it is control register or status register. When we are reading, it is status register. When we are writing from microprocessor, it is control register. Write signal, when this signal is low, microprocessor unit either writes in the control register or sends output to the data buffer. Read, when this signal goes low, microprocessor unit either reads from the status register or accepts data from the data buffer. Reset, a high on this pin is used to reset 8251. Clock, this is clock input, and this is usually connected to the system clock of 8085 microprocessor. Control register, 16-bit register for a control word consists of two parts, two independent bytes 8 plus 8, that is mode word and command word. So, control register is divided into two parts, that is mode word plus command word. Mode word specifies the general characteristics of operation such as baud rate means speed, parity, number of bits, etc. Whereas command word enables the data transmission and reception. A register can be accessed as an output port when control C/D pin is high. Status register, it checks the ready status of the peripheral. Status word in the status register provides the information concerning register status and transmission errors. Data register, used as an input and output port when CD is low. The third section of this 8251 is modem control. It is having 4 pins. First is DSR. These all 4 pins are active low, that is activated when these pins are 0. First is DSR, data set ready, checks if the data set is ready when communicating with the modem. DTR, data terminal ready, check indicates the device is ready to accept data when 8251 is communicating with the modem. CTS, clear to send, that is 8251 is unable to transmit the serial data. RTS, request to send data, low on this pin indicates modem that the receiver is ready to receive a data byte from the modem. Then fourth section is the transmitter section. It accepts the parallel data from microprocessor unit and converts into the serial data. It is having two registers, buffer register to hold 8 bits, then output register to convert 8 bits into a stream of 8 serial bits. The microprocessor writes a byte in the buffer register. Whenever the output register is empty, the contents of buffer register is transferred to output register. It consists of this transmitter section consists of 3 outputs and 1 input signal, that is TXD, transmitter data output, TXC, transmitter clock input, TX ready, transmitter ready, and TXE, transmitter empty. Fifth section is the receiver section. It accepts serial data on the RxD pin and converts into the parallel data to send to the microprocessor. It is also having two registers, a receiver input register which receives the serial bits one by one, and buffer register which contains the 8 bits. It is having 3 pins, Rx ready, receiver ready output, RxD, receive data input, that is which receives the data input one by one serially, and RxC, receiver clock input, clock signal that controls the rate at which the bits are received by the UART. So, these are the 5 main sections of 8251, and its main function is to convert serial data into parallel data to send to microprocessor, or to accept data from microprocessor in parallel form and to convert it into serial form. Second peripheral chip is the 8253. This is programmable interval timer, PIT. It is used to bring down the frequency to the desired level. It consists of 3 counters. Each counter works independently and is programmed separately to divide the clock frequency by a number from 1 to 65536. There are 4 port addresses needed for a single 8253 given by A0, A1 and CS, that is chip select. A0 and A1 are the address lines. These 4 port addresses are for counter 0, counter 1, counter 2, and fourth one is for the control register. The Intel 8253 is programmable interval timer which performs timing and counting operations. They are primarily designed for Intel 8085 processors, but later used for 86 systems. The timer has 3 counters, also known as channels, and each channel can be programmed to operate in one of the 6 modes. There are 6 operating modes, and once programmed, the channel can perform their tasks independently. That means all the 3 channels are work independently, perform their functions independently, and they can perform the duty of operate in 1 to 6 operating modes. This is a pin diagram of 8253. This is a 24 pin IC, and this is a block diagram of PIT 8253. It contains data bus buffer, then read write control logic, then control word register, and there are 3 counters, counter 0, counter 1 and counter 3, which can be used independently. So, there are 3 counters or timers which are labeled as counter 0, counter 1 and counter 2. Each counter has 2 input pins. Here are 2 input pins, that is clock and gate, and 1 output pin out for data output. These 3 counters are 16-bit down counters, independent of each other, and can be easily read by CPU microprocessor 8085. Data pins D0 to D7 allows the CPU to access various registers inside the 8253 for both read and write operations. Read write control logic. This block contains 5 pins, that is read bar, that is read signal, write bar, write signal, bar means these signals are active low, CS bar, chip select signal, and A0 and A1 are the address lines. There are 6 operating modes of 8253. Operating modes of PIT is changed by setting the above hardware signals. For example, to write to the control word register, one needs CS bar is 0, read bar is 1, write bar is 0. Write bar 0 means we have to write something to 8253, and A1 and A0 must be 1. So, when both A1 and A0 are 1 and 1, we can 8085 can access control word register of 8253. Each of these 3 counters must be programmed separately. Control byte must be first written into the control register. The programmer can not only write the value of divisor into 8253, but reads the content of the counter at any given time as well. All these 3 counters are down counters. To program a given counter to divide the clock input frequency, one must send the divisor to the specific counter register. Although all these 3 counters share the same control register, but the divisor register are different for these 3 counters. For example, the port address of 8253 is counter 0 is 94, then counter 1 is 95H, counter 2 is 96H, and obviously control register is 97H. Control word register. This register contains the programmed information which will be sent by the microprocessor to the device. It defines how the PIT works logically. Each access to these ports takes about 1 microsecond. To initialize the counters, the microprocessor must write a control word in this register. This can be setting the proper values of pins of read write control logic, that is write bar must be 0 and CS bar must be 0, and A0 and A1 must be 1 and 1, and then by sending the control word to 8253 by using D0 to D7 data bus. This is the pattern of the control word. It is having 8 bits. The D0 indicates whether it is binary or BCD. D1, D2 and D3 or for the mode selections. These are D1, D2 and D3 of the control word setting the operating mode. There are 6 modes in total. For mode 2 and 3, the D3 bit is ignored. So, the missing modes 6 and 7 are aliases for mode 2 and 3, because these are 3 bits. We can select up to 8 modes, but the actual modes are 6. So, modes 6 and 7 are also used for mode 2 and 3. Notice that modes 0, 2, 3 and 4 For mode 0, 2, 3 and 4, gate must be set to high to enable counting. For mode 5, the rising edge of the gate starts the count. And SC0 and SC1 indicates whether to which register has to be, which counter is to be select counter. It is having 6 operating modes, that is mode 0 is interrupt on terminal count. Mode 1, it is hardware triggered programmable one shoot mode. Mode 2, rate generator divide by n counter. Mode 3, square wave rate generator. Mode 4, software triggered strobe. Mode 5, hardware triggered strobe. So, there are 6 working modes, 6 operating modes which can be selected by using this 3 bits M0, M1 and M2 and 8253. Any one of the counter can be operating in these 6 out of these 6 working modes, but all these counters work separately. Then third chip is 8255. It is PPI, programmable peripheral interface. Its primarily function is to transfer data under various conditions. This is a 40 pin IC. Out of these 40 pins, 24 pins are used for input output functions. ਇਸ ਪਿਨ ਦੇ ਵਿੱਚ ਟੋਟਲ 40 ਪਿਨਸ ਹਨ ਐਂਡ ਇਹਨਾਂ 40 ਪਿਨਸ ਦੇ ਵਿੱਚੋਂ 24 ਪਿਨਸ ਯੂਜ਼ ਹੁੰਦੀਆਂ ਨੇ ਇਨਪੁਟ ਆਊਟਪੁੱਟ ਲਈ. The function of 8255A classified according to two modes. ਇਹਦੇ ਦੋ working modes ਹਨ. First is BSR mode, ਉਹ ਹੈ ਜੀ bit set reset mode. ਇਹ ਸਿਰਫ port C ਲਈ ਹੈ ਕਿਉਂਕਿ ਇਹਦੇ ਵਿੱਚ 3 ports ਹਨ, port A, port B and port C. दूसरा वर्किंग मोड है इनपुट आउटपुट मोड. ये तीनों पोर्ट्स से एप्लीकेबल है, पोर्ट ए ते भी, पोर्ट बी एंड पोर्ट सी. दिस इज द ब्लॉक डायग्राम ऑफ 8255. इट इज हैविंग 3 ports, that is port A, port B and these 2 parts indicates port C, that is port C is divided into 2 parts and these total 4 parts are divided into 2 groups, that is group A and group B. This is group A control and this is group B control. It is having a data bus buffer to transfer the data from 8085 and it is also having a read write control logic. There are total 40 pins. Out of these 40 pins, these 24 pins are used for input output functions. This is the block diagram of 8255. It is a 40 pin IC. The 8255 is PPI, programmable peripheral interface, is mainly used to interface peripheral devices with the CPU. It is having 3 8-bit ports, namely port A, port B and port C. Port C is further subdivided into 2 4-bit ports, port C upper which contains port PC4 to PC7 and port C lower which contains PC0 to PC3. For the further programming, these 3 ports are divided into 2 groups, that is group A, it contains port A plus port C upper and group B, it contains port B and port C lower. The data transfer between the CPU and 8255 takes place through the data bus D0 to D7 and with the help of read and write bar signals. It also uses a CS bar signal, that is for chip select. Signals CS bar A1 and A0 are used in conjunction to select different ports and control register, because there are 3 ports A, B and C and 1 control register. To select any one of these register and control register, port and control register, CS bar A1 and A0 are used in conjunction. Each port has unique address, हर एक port का अपना अलग-अलग address होएगा. Input in ਅਤੇ out instructions use करके, in and out instructions use करके, we can read or write data to a particular port. This is a pattern of control word of 8255. It is a 8-bit word. D0 is for group B, D0, D1 and D2 or for group B. D0 is for port C lower, 1 means input, 0 means output. D1 is for port B, 1 means input, 0 means output, and D2 is for mode selection, 0 means mode 0 and 1 means mode 1. We have already discussed that it is having two operating modes, BSR and input output mode. In input output mode, there are further three modes, 0, 1 and 2. So, this D2 is to indicate whether there is mode 0 and mode 1 for group B. D3 is for port C upper, D4 is port A, and D5 and D6 are for mode selection. 00 means mode 0, 01 means mode 1, 11 or 10 and 11 means mode 2, and D7 is mode set flag, 1 means active. There are two basic operational modes of 8255. First is bit set reset mode, BSR mode, and second one is the input output mode, IO mode. The two modes are selected on the basis of value present in the D7 bit. This is D7. When D7 is equal to 1, there is input output mode. When D7 is equal to 0, it operates in bit set reset BSR mode. The bit set reset mode is applicable to port C only. In this mode, any bit of the port C, that is from PC0 to PC7, can be set or reset by suitably loading the control register. BSR mode and IO mode are independent. Selection of BSR mode does not affect the operation of other ports in IO mode. So, in BSR mode, D7 bit is always 0. Bit D6, D5 and D4 are don't care conditions. These three bits D4, D5 and D6 are don't care conditions. D1, D2 and D3 are used to select the particular pin of port C, and D0 is used to set or reset the selected pin. If D0 is 0, then we want to reset that particular pin, and if D0 is 1, we want to set that particular pin of the port C. This is a bit selection of port C. We can select any pin of port C from PC0 to PC7 by using these three bits D1, D2 and D3 of the control word register. In input output mode, in this mode the D7 bit of the control word register is 1, and there are three input output modes, mode 0, mode 1 and mode 2. Mode 0 is a simple input output mode. It is for all the three ports, port A, port B and port C. Mode 1 is the strobe handshaking mode, input output mode. It is only for mode A and mode B, and in this case port A and port B, in this case port C is used for the handshaking. Whereas mode 2, this is a handshaking bidirectional input output mode. In this only port A is used. That means in mode 0 all the three ports are used. In mode 1 only port A and port B is used, and in mode 2 only port A is used. And next chip is 8257, that is DMA controller. DMA means direct memory access. The basic idea of DMA is to transfer blocks of data directly between memory and peripherals. The data don't go through the microprocessor, but in data bus of microprocessor is occupied. DMA is implemented using a DMA controller. DMA controller acts as a slave to processor and receives instructions from processor. This slide shows the two diagrams. In first, there is a data transfer through the CPU. So, in this case all the system buses of CPU are used, and data is transferred from between memory and input output devices through CPU. In second diagram, the system buses of CPU are used, but data is directly transferred between input output and memory, and all these controlled by the DMA controller. This is a data transfer by using DMA controller. In this case, there is a direct data transfer between input output and memory by through DMA controller. A DMA controller interfaces with several peripherals that may request DMA, direct memory access. The controller decides the priority of simultaneous DMA request coming from the peripherals and CPU, and provides memory address for data transfer. The DMA controller used with 8085 is 8257. Steps in a DMA operation: processor initiates the DMA controller, then data transfer. When ready, I/O device informs the DMA controller. DMA controller starts the data transfer, obtain buses from the microprocessor, places memory address and appropriate control signals.